Okay, so today we are talking about automating solver. So it's our last day of class, December 8th. So there's a file to download here. So go ahead and get that file downloaded and opened up. This example is actually one that I used to use earlier, like, 15 years ago or so. I used to use this example to go across many different lectures, and we would do lots of different examples in it. Like we would use it for doing forms. We would use it for requesting information from a website. We would use it for automating solver. We'd use it for doing charts. So it's really a a large project. And we're going to focus on just a part of it. So a lot of the code is already here for us, but we're focusing on the part that's about automating solver. So we'll get that file downloaded and open. And first, we want to start off by making sure that you've got the solver add-in. Is there anyone who's looking at me saying, I'm not sure if I have the solver add-in available? Okay, so it looks like there's a few of us. And so let's go ahead and make sure we've got it. So I'm going to choose File, Options. I'm not entirely sure that I have it. So Files, Options, and then I'll choose Add-ins over here. So Files, Options, Add-ins. And then bottom left-hand corner, it'll say Manage Excel Add-ins. That's what I want to do. So I'll click on Go. And we should have one called the Solver Add-in. We'll go ahead and make sure that's checked. Then we'll say OK. And when you have that add-in installed, it shows up on the Data tab. So you should come over here to the far right, and you should see this little Analyze group with Solver written in it. Need to import data? Not really. Well, we do, but we'll import it already. OK. Any questions on getting Solver going? Now, there is Solver for Mac, and I know that the stuff that actually brings the data in this example won't run, but that the data, there's like data to start with here. So as long as you don't clear anything out, then we should be okay, even if you're working on Mac here today. But the truth is, I'm not sure how well what we're doing records on the Mac. We'll find out if it works or not. All right, so let me just kind of give you an overview of this project. So here's the idea. What we're trying to do is we're trying to say, given a particular set of stocks. So in this case, I've got 8 or so, maybe 10 stocks selected. Given a particular set of stocks, what is the right way to balance the portfolio of those stocks such that my expected return will be, for a given expected return, that I will minimize the risk. So if I were to look at each one of these stocks individually, kind of over the past, however long a period of time I'm interested in looking, we'll say there is, some of these stocks are going to have a certain return. That'll be what we'll use as our expected return. So what's the historic return? We'll use that as the expected future return. So in this basket, I can get anywhere from the very lowest performing stock. I could make my whole portfolio just that one stock, everything else 0, and then I would get the lowest expected return. Or I could put everything in the highest performing stock, and then my expected return would be that particular return. But anytime I'm investing in just a single stock, then my risk is going to be going up. And so I want to diversify the portfolio and say, listen, I'm not going to shoot for the lowest. I'm not going to shoot for the highest. I want to kind of get somewhere in the middle. And wherever I pick, whatever expected return I pick there, I want to balance the portfolio such that it minimizes the risk, because of the different volatilities in the stocks. So that's the task that we're going after today. Whew. And the truth is, if we have some of you who are finance majors, you may understand this model better than I do. And so if I misspeak, don't feel shy to correct me on this. But I think I've done this enough times that I think I've got it figured out, probably. Questions? Okay. So I think the add tickers just kind of brings up a form. So this is an example we used to do in class to kind of build a form to bring tickers in, but ultimately you can just enter the tickers here beginning in column A2 or cell A2 and going down. So the tickers that we want to use for this. Those are probably all still valid tickers. Now, interestingly, we're not going to run this in class today, but if you do click on get data, it should prompt you and say, hold on a second, slow down, because getting this data requires an API key. So what we're doing is we're asking someone to give us some historic data on stocks, like every month, information on what this stock was performing kind of in month increments over a long historic period of time. Used to be that we could get this pretty easily off of finance.yahoo.com, and I'm not sure why that example quit working, but it quit working. And so I went and found this site, which is, so don't do this unless you've done what I'm about to show you to do. alphavantage.com, which provides access to historic stock data. You'll sign up for a free API key. The free key is limited to 5 requests a minute, so you can make a request like every 12 seconds or so. And you can make a maximum of 500 per day. The whole idea is here that you'll kind of play around with this, and then when you want to get a serious amount of data, you'll pay for whatever you have to do to get more volume out of it. And so the code is behind here, how to use an API key in this environment to be able to authenticate yourself and pull data from a for pay service. So we're not going to go over that today. Well, maybe at the end we'll go take a look at it if we have time. But that's just letting you know that's here, and the code is all here for you to track down. How would you find the code that gets executed by this button? Right-click the button, choose Assign Macro, and then click Edit, and that'll take you right to the place that the code is running for that particular button. So, questions? When you do get the data, which we won't do in class today, but when you do get that data, what it will do is it uses this page to bring in the raw data. So we've got, for whatever period we're asking for, we've got various measures here, and I forget exactly what they are. We can go through the code and figure it out. But then ultimately, we're using that to calculate, we're bringing in the raw data so we can calculate the percentage change. Because this is the month-over-month percentage change. So sometimes it's going up, sometimes it's going down, but this is how we're going to get our measure of volatility for each one of these stocks. So we'll look at this vector of changes, kind of here at the various month endings, and that will give us a sense of what the volatility is. We're gonna kind of get that data and get the percentage change column for every one of these tickers. So what do I have here? I've got 10 of them right now. And so this is just kind of a staging area to bring in the raw data and then calculate this volatility column, which will be what actually comes into the consolidate measure. So then we've got this table that says, all right, well, this is the volatility that we observed for American Express, for Apple, for Ford, for IBM, and so forth. And so this is just the kind of getting the underlying data to be able to set Solver loose. So what is Solver? Solver then is, imagine the idea that you've got, actually, let's do this. How many of you would say, you know what, I'm already pretty familiar with Solver? I've learned it in other classes. Some of you are kind of saying, no, not really, and others are saying a little bit iffy. So imagine that, in fact, let's just look at the model that we have here. So on the model sheet, here's the idea behind this particular model. What we're saying is that we've got all of our 10 stock tickers here. And right now they are equally weighted. We are just saying put 1/10 of whatever money we have to invest, put 1/10 into American Express, put 1/10 into Apple, put 1/10 into Ford, and so on. And so the mean then, this is going to be this is the average return. So if we just kind of average across all those monthly returns, like every month it's either going up or down a little bit, if we take that average, this then is going to be the average monthly return for that stock across this period. So here we've got General Electric that across the period of data that we have in the worksheet right now, it actually on average lost money, whereas these other ones were up a little bit. Who's our highest one? Looks like Apple at Microsoft higher, Microsoft's 2. Southwest. Oh, Southwest. So we know this is not recent data because Southwest, all airlines are struggling right now. So this is, oh yeah, it's definitely from before COVID because I haven't done this example since COVID hit. So that's what those numbers are. And so this right here, this just tells this is just the minimum of those means. This is the maximum. So no matter how I chose to allocate this, I'm not going to expect to lose less than we're losing over here from General Electric. I have no reason to expect that we'll earn more than we're earning from Southwest Airlines here. So that's just what those maximums and minimums are. Now, because we're allocating 100% of the money that we have into these different ones, we have to make sure that all these weights that we put in here sum up to 1. And so that's what this cell is doing here. It's just the sum of that vector of weights. And so this then is really the model that we're trying to do. What we're trying to do is right here. We're trying to minimize the portfolio variance. So how much variance we have in the portfolio is the measure of risk. The higher the variance, the more risk there is, the less variance there is in the whole portfolio, that's lowering the risk. And so the idea here is we're saying, listen, what we'd like to do is we would like to figure out how should we really be allocating these stocks so that we can achieve a desired rate of return. That's the constraint here, but to be able to achieve it in such a way that we are minimizing the amount of risk that we're accepting here. So let's just see if we could do that right now. So right now, what's our constraint? Our constraint is the very highest one. So that's not a very good constraint. Let's kind of go ahead and pull this down to like maybe 0.01. So right now I'm getting 0.0132. So I have met this constraint that the expected return, so the expected return that I'm going to get off of this portfolio is above what my required return is. Now the question is, could I change these numbers in such a way that I could still have this statement be true, that this number is greater than or equal to this one, and reduce the amount of risk that I'm taking on? You just take that number and kind of paste it right here as the starting point. So this is the number that we started with. So I'm just gonna try to change these. So let's see. I would probably, maybe I'm going to increase Apple. So I'm going to take 0.2 of Apple, and let me take maybe just 0.05 of Southwest and 0.05 of Oracle. Success. So I managed, oh no, I didn't. I raised the portfolio variance, right? So now I've got a little bit more variance. I have a little bit more variance, a little more risk than I had before. Darn it. So that wasn't a good one. Let me kind of go back on that one. 0.1. Maybe I'll put Apple to 0.05 and move Southwest up to 0.1. What did that do for me? So that decreased my risk, but now I'm below my threshold. I'm a little bit below this constraint. Oh, I'm still 0.9. Good. Thank you for noticing that. So 0.1. Okay. I'm just trying to figure out why. I've got 2 5s. Oh, I got to move I got to move someone to 2. There we go. 0.3. Okay. This time I did it. So I have slightly less risk, and I'm still meeting this constraint. And so that's what Solver's going to do for me. It's going to do that thousands and thousands of times a second. And it's going to say, you know, when I adjusted this one, things got a little bit worse. And so adjust that one the other way the next time. And it's going to make small steps and just do everything it can to figure out what's the best allocation of that basket. So this is task where you can't just like make an equation and solve it, right? You've got to guess and check. And that's what Solver does. It does it really fast. And it's designed to say, all right, as we make changes, observe how the overall model is going, and let's try to make the changes in the way that'll push it the direction that we're trying to go. And so when you're setting up a Solver model, you always have to have a target. What are we trying to do? And in this case, what is it that we're trying to do? What is the goal that we're telling Solver to do? Yeah. minimize the risk. Yeah, so minimize the risk. And then you're almost always subject to some constraints. So you're saying, I want you to minimize the risk. So change, you're allowed to change these numbers. You're trying to make this number go as low as possible, but you're subject to the constraint that you can't let the mean return go lower than the expected return. So this is what we're asking it to do. And whatever you put in here, they've got to sum up to 1. So given those two constraints, try to move this number as low as possible. So solver's goal is always trying to make something go either as high as possible, make something go as low as possible, or trying to get to a targeted number. So we might say, get as close to 17 as you can in this cell. And that's what it's going to kind of start playing around to see if it can happen. Okay, questions? For those of you that are kind of new to solver, any questions on the idea of what solver is? It's an add-in, and so it's not made by Microsoft. Solver is actually made by a company called Frontline Systems. And they actually now have a version of solver that is an add-in that is actually kind of added in a different way than that add-in was. It's kind of the new approach. Let's see if it's here. It's not installed on this machine, but I wouldn't be surprised if on yours you actually have another solver kind of up here on the very right of your home tab. Anyone have that other solver on the home tab? It's actually made by the same company, Frontline Systems, made the one that's there as well as the one that's the kind of the traditional one that's been in Excel for decades. And we cannot automate the kind of the new style one. We can't automate it in the same way that we can automate the classic one. All right. So what I'm going to do here is before we record ourselves, and that's what we're going to do. We're going to record ourselves doing an optimization model, and then we're going to go and edit that code. But before we record it, I want to go through it first once. So you've got some practice doing it before we're kind of setting that code down in lines of code. So to do this, I'm going to make sure, number one, I have to be on the sheet that I want to optimize. And that's one of the things that's not especially kind of clear in your code. So almost everything else we do in Excel, you can say, I don't really care what the active sheet is. I want to change something on a different sheet. I want to change something on sheet 3. That sheet doesn't have to be active. I can just tell it sheet 3.cells, whatever, gets a new value. But for solver, we actually have to have the sheet active that we're going to be running the model on. So I'm going to make sure that sheet is active. I'm going to come to my data tab and I'm going to open the solver add. Okay, so the first thing is I'm going to set my objective. And my objective is to set my portfolio variance. I think I could probably do the variance or the standard deviation. Standard deviation is just the square root. Standard deviation is the square root of the variance. And I'm not going to maximize that. I want to minimize variance. And I'm going to tell it which cells do I want to change. I'll come here and tell it I'm trying to change these weights subject to these constraints. So I'm going to add in those two constraints. So the first constraint is that my expected return has to be greater than or equal to my required return. And if I say okay, it'll take me back to the other thing. I can say add another constraint, or I can just say add this one, and it's ready to add the next one, which is that my sum of weights has to be equal to 1. Then I'll say okay. So now I've got those two constraints in there. Make unconstrained variables non-negative. Yeah, I think that's right. So I don't want to put any of these negative. I'm going to try to short any of these stocks. So I'm going to leave that checked here. And using the nonlinear, I think GRG, the truth is, I don't know that much about what these different ones mean. I'm just going to accept the default here. And it used to be that we came into options, but this was the option that we're interested in, allowing non-negative, and that's kind of right here on the front screen now.
Did you name the ranges?
So did I name these ranges? These ranges, yeah, those cells are named, which is why that these changed. That's why these went to names. And I'll go ahead and click solve. And then get this kind of result box up here. So, hey, good news, we found a solution. We can either keep the solution by saying okay, or cancel, we can discard it. And I'm just going to say okay. So now we can see it really has changed these weights a lot. It's saying, listen, you don't want any Southwest Airlines. It's really kind of interesting that it's predicting that here just kind of shortly before COVID, because this would have been, yeah, this was, last time I did this was in 2019. It's kind of neat. What's that? So that's probably because you had the required return set at the very highest number. So if your required return is set to Southwest, that's right. You have to get that expected return, you have to dump everything into that stock. Yeah, so it'll be different. This will solve differently based on what you said as your required return here. This is what I meant my required expected return. So that's the constraint that we're after. Questions? How many cell changes did it make in that half a second or so that it took to run? Probably tens of thousands. You can crank through changes really, really quickly. All right, excellent. So I think now we're ready to record ourselves doing that to get to look at this. So, and the truth is that right now that solver model is now a part of this worksheet. So if I come back to solver, this thing is still here. And so if what I'm trying to do is I just saying, you know what, my input data is going to change, but the dimensions of the model are not going to change. I don't actually have to do very much to automate solver. I don't have to automate the configuration of it because this configuration will work. I could just tell it to run again. We'll see how to tell it to run with VBA. I've changed my input data, run the solver, change the input data, run the solver. But if, like this one, if the size of the model changes, that's a different story. Because now we've got to change the dimensions that we're working with. So if right now our basket is 10 stocks, if we're going to have 12 stocks, it would be a different range. Now you've noticed I named that range, and that would actually make it a little bit easier to get away without changing it. But the point is, sometimes you need to be able to change the model between runs. And so that's what we're going to be going after today. Okay, so I'm going to cancel this, close this, and I'm going to start recording. So back to my developer tab. Oh, really? My developer tab's gone. So let me go ahead and come back to options, customize ribbon, developer. Okay, on my developer tab, I'm going to record macro. And actually, let's do this. I'm going to stop recording. It would probably be pretty good if I was recording myself actually selecting the model sheet, because that way it'll record, select that model sheet, which is part of what I need to do because this has to be selected. The model sheet has to be selected when I run it. So I'm just going to be off the model sheet. I'm going to record the macro. Macro one's a great name. We'll be moving the code that it generates. I will select the model, and now I'll go ahead and open up solver. Now, the first thing I want to do is I do not know what the user may have done to the model here. So there's a model on this sheet. The user may have changed it. And so before I start adding constraints, I'm going to say, you know what? Let's go ahead and reset this whole thing. So I'm going to click right here where it says reset all. That's going to say, let's just wipe this thing out. Reset everything. Yep. So now we're recording the fact that we've cleared out the model. And now we'll build the model with just the specifications that we want. And we'll go through that same process. So portfolio variance is going to be my objective. I'm going to set it. Oh, you know what? Might be interesting. I wonder if I can get to it here. Might have been kind of nice if we split the screen and we were actually seeing it, put this stuff in, but it doesn't write that much and we can kind of remember what we've done. So I'm going to minimize by changing cells, this range. I'll add my constraints back in. This has to be greater than or equal to this. Sum of weights has to be equal to 1. I don't think I actually have to uncheck that and check it. I think it'll record that as non-negative. I think we're okay. I'll go ahead and click solve. I'll say okay on this, and I'll stop recording. Then I'm going to go take a look in my modules. There was already a module 1 that had all of our code there that we started with. So this would have created a new recording session in module 2. And so this is what it recorded. Select the model, or select the sheet, the model sheet, reset solver. And now this next one's a little bit weird. It's called solver OK. Now, this is, do you remember that Microsoft didn't write solver? Solver is written by this company, Frontline Systems, which means that they're also the ones that wrote the VBA recorder, the macro recorder for this add-in. So if you thought, just raise your hand if some of the times you see what the macro recorder recorded and you went, wow, that seems like a really weird way to do it. Yeah, this is going to be even weirder. You know, Microsoft does strange things, but they're pretty consistent. And this is now going to be a little bit different for us. So it's a strange name for solver OK. That's what the method's called. We're setting the cell to a particular cell. That looks great. Min max value equals 2. What do you suppose that means? It's actually, I'm not sure if it's the second option, but.
So it's the buttons, max is 1, min is 2, and the value is 3.
Right. I'm not sure what max and value is. It may be just what it is. But because I recorded myself saying to minimize, I can recognize this as, oh, yeah, are we going to maximum, minimum, or a value? And the answer is 2, which means minimize. We could quickly record ourselves and find out what maximum and what to a value is. Now, value of 0, what do you think? That's right. If I was setting it to a value, that would be relevant, but it's not, but it still records it anyway. That's okay. And then by changing, here's the range. Kind of interesting, that was a named range, but it still picks it up as this particular formula. Using engine number 1, there we go. So it's not telling us anything about the constrained, non-constrained variables to be non-negative, so it must just be the default, so it didn't record it. So our next line, solver add, we're adding a constraint. And we're saying that D10 is got to be, what do you think 3 is? Relation 3, greater than or equal to. And then in this case, it really did do the formula here. Now, interesting, this is called formula text. That's going to come up here to bite us in just a second, but we'll correct that error when we get to it. And then G7, which is our sum of weights, has to be equal to 1. Then this is a strange one here. Does this line look familiar? Yeah, this is just the same solver OK that we had up above. It's exactly the same information. Why does it record it more than once? No idea. Would it hurt for us to leave it here? No, it's setting the things to exactly the same as they're already set, but I don't need it. So I'm going to get rid of it. And I'm going to look at the next one. And I'm going to say, that looks familiar. You know what? It's exactly the same as the one above. I'm going to get rid of that one as well. So now I've got this reduced down a little bit. So we're saying, make sure we're on the right sheet, reset the solver, set up exactly what we're trying to achieve, set what the goal is, and how we're going to achieve it, add in the constraints, tell it to solve. Just run it and see what happens. Yeah.
So we're going to link it to the optimize button, right?
Ultimately, we're going to link it to this optimize button. That's correct. Oh, so what you're saying is, so what's the point here, Professor Allen? Why are you saying make sure that we have the sheet selected? Since where this is going to be activated from is right here from optimize. And it's going to be optimize will run this once, but where we're headed with this is what we'd like to do is we would like to say, all right, let's go ahead and build in a chart that will do an efficient frontier. In other words, what we'd like to see is, well, what if our required mean is really low? What if it's a little bit more? What if it's a little more? What's a little more? What if it's all the way as high as we can go? And that will plot an efficiency frontier for us that will say, listen, you can be anywhere to the right of this curve. You can accept more risk for a given level of required return, but there's no way to get to the left of the curve. So what you really want to be is you want to be somewhere on that curve. So it'll let us graphically see that. And to do that, we're going to be running this multiple times. And so when that one runs, it does not necessarily need to have, because there'll be other ways for us to invoke this. But the main thing that I wanted to point that out is that that took me hours to figure out one day when I was trying to learn why isn't my code running. I just didn't realize that the sheet was no longer active, that my code was assuming it was active. Okay, let me go ahead and change this and see how it see what it does to optimize. Let me kind of put this up to maybe 0.15, 0.015.
Professor Allen, it looks like it didn't work because the sum of weights at 0.51.
Oh, yeah. What's wrong? This took me a long time to figure out too. The fifth line. 1, 2, 3, 4, 5. Yeah. So this looks pretty good. I mean, doesn't it? What's wrong? This is somehow when we did it, it worked, but when we recorded it, it didn't work. In fact, it makes me wonder, what does it even say in the solver if I go and look at it? Is it even configured correctly now? Ah, look, it's missing that constraint. It didn't like something about it. It didn't complain about it. It didn't give us an error, but it didn't actually add that constraint. You want to see how to fix it? Please, Professor, show us how. Notice that the parameter here is formula text. This needs to be a formula. I guess a named range qualifies as a formula, but an integer doesn't. So all I'm going to do is I'm going to put an equal sign in front of that. And that will turn that into a formula. And now if I run it, in fact, is the optimize button already connected? Maybe I will just go ahead and connect this. Oh, it's called macro 1 now, so I won't connect. I'll just go run macro 1. And so now it looks like it has respected the 1. And if I come back to solver, we'll see that the solver is configured with that additional constraint. Who knows, but there's better help now available in the world of Google to help you track that one down, but it was hours to find out why that wasn't working. One sad day. Yeah.
Mine says 1.20001 on the sum of weights, and I did what?
Oh, so you've got 1 and then a little tiny bit more than 1, yeah?
Yeah.
Yeah, and that's the nature of working with solver, is that solver is going to say, that's close enough. And so, if that bothered you, just put a cell format on that cell.
Okay. And then the other question is, we recorded this macro and it put in that 1. We didn't put that in that 1. So what you're saying is basically like, when we record this macro, it almost records it incorrectly than it's supposed to?
We did put the 1 in. So
we put that 1 in?
We came in here and we said, we're going to add that. We're adding the constraint where we said our sum of weights has to be equal to 1.
Yeah, but then when it's recorded into the macro, that's the incorrect format. We need to have an equal 1. So my question is, how in the world did you ever figure that out when you could? Basically, what I'm saying is, you do it without recording it, and it works. You record it, and then if you were to just run that macro, it then would not work.
Right. Yeah. And it looks, you look at it, you think that looks exactly right. Yeah. I don't remember how I figured it out. I'm sure Google was heavily involved. I am also equally sure I didn't ever find anyone saying, hey, by the way, this thing records wrong. But it might have been that I came across a more complex one in there that actually showed it as a formula. I went, I wonder. But if I put a complex formula, 1 times 1 times 1 times 1 times 1, divided by 1. And that worked. And I kind of probably backed it off from there. I'm not sure that's what I did, but that sounds like something that could have happened. Okay, so yeah, but even the one that's done by Microsoft, the web query wizard, if you remember, it records a line that fails when you try to play it back as well. So I guess we'll give the guys at Frontline Systems a little bit of slack. Although it seems like after decades they should have fixed it. Maybe they don't know. All right. Okay, so now what we need to do is kind of take these building blocks and put them into our overall system. Because what we're doing here is, yeah, let's go ahead and get the optimize button working first. So I'm going to come back to module 1, and let's just kind of take a look at what we've got here. So we've got one subprocedure here that just shows the ticker form. That's pretty straightforward. This one then is going to get the ticker data. So when I run get ticker data, it's going to blow away all the old data, build the new sheets that it needs, and then it's going to go pull the data in. And we've got other subprocedures that go and do all of those steps. So when we kind of run this whole thing, we are not going to have it get the data because kind of a whole process to go through to get that set up. Build model then is going to say, all right, given the data that we have, let's do the summarization that we need, configure the solver, run the solver, and then find the efficient frontier. So first thing it's going to try to do is config solver. Oh, there's one more thing I want to do before we bring this code over. Let me come back to module 2. And I'm going to run this. I want you to notice what it does. All right, when it runs, it brings this up. I do not want that to come up 10 times while we're trying to build that efficient frontier, running this model multiple times. Good news, there's a way to suppress it. Solver solve has an argument called user finish. It's a Boolean argument, true or false. What should we put? User finish true or user finish false? Yeah, we would like to not show that to the user. However, user finish false is what shows the dialog box. It's the default. So we have to put user finish true, which seems exactly backwards to me. And I'm glad that it seems backwards to you too. That way I'm not just kind of the weird one here. So I could say user finish : equals true, or I can just say, because it's the first one, I can just say true here. So now when we run that, it should optimize, change this to 017. Now that should optimize it without, did we see it change? I wasn't paying attention. So, so good. Okay, so now we're in good shape. So now what I'd like to do is I'd like to kind of bring the configuration part of this over. And bring it into my config solver subprocedure. And in fact, I should have got one more line there, because to configure that solver, that sheet has to be selected. Then the line to run the solver is just one line here. But like configuring it, the model sheet has to be selected when it's running.
Why separate those out?
The question is, why separate these out? And the answer is that when I run this multiple times to find that efficiency frontier, the model is all going to be the same size. I'm not changing the model, so there's no need for me to reconfigure the model in between. I'm changing the parameters, so I'll come here and say, add a little bit more to my constraint on return and find out what the optimization is for that. So I can run that model multiple times without changing the setup of it. But your point is well taken, is that I could leave them together, because how long does it take to configure the solver? It takes, less than, just a few milliseconds to configure it. So it wouldn't be a big deal to leave them together. And so now I think let's kind of take a look at what find frontier does. So find frontier sets us a minimum and a maximum number as single. And then it just reads those in from the worksheet. So min return and max return are these two cells here. Let's click these. And then for however many increments we have, we'll do one more because we're going from 0 to 10 in this case. And then we're just going to change what our required return is. We're going to put a new value in here. And what's the value going to be? It's going to be the minimum return plus 1/10 of the increment. Now, 1/10 of the distance between the minimum and the maximum. So the first time through, x will be 0. So this will be, sorry, this will be 0/10. So that will be the minimum amount. The next time through, it will be 1/10, 2/10, 3/10, and so forth. So we're just going to move that up in 10% increments as we go. Then it will run solver and copy the information, portfolio variance and required return. It's going to copy that over to a particular location onto our range. And what is this one doing? Oh, I think I'm recording. Yes, I am. I'm actually recording what those weights are. So we're keeping track of what the deviation and required return was, as well as the weights that got those for us. Then we're making the chart, building this chart here, or configuring this chart. We're actually deleting the chart and then rebuilding it. Okay. So I think I kind of want to do these one at a time. So I'm going to come here to build model. Just put a breakpoint in. I'll run this one. Object has no title. Oh, you know what? I think I put the breakpoint, but I didn't activate the one I wanted to be on. So let's try that again. Let's put the code here and run this one. Okay. So I'll run that one. Configure the solver. We'll go and get my solver configured. Running the solver should get my first one set. We saw it adapt. And then find frontier. You can kind of see it going through several times. Looks like it's failing on the chart. Probably because they've changed the way this works. I think I need to add a chart here. So s dot chart dot has title equals true. Yeah, that's what I needed to do. So I needed to add this, tell it that it does have a title so that it can actually put this title on it. Then run that through, and that is a really bad efficiency frontier. So what it means is that since I started this example, since I last ran this example, it looks like it builds the chart differently. And it might have been because we had that, because we interrupted there. So let me try that again. See, my data is already set up, so I should be able to just do find frontier. So the chart's not building the way it should, but at least we see what we're really after here is that we've got the different weights that it did each time it's trying to optimize the portfolio given the constraints. When we get up to the required return as the maximum return, the only option to do is to put all that into the single best performing stock from the historic data. Questions on automating solver? Go on which one?
Like that, like
Oh, to where I had to change the chart. XY scatter, no markers. You just see what happens if I put an XY scatter, build an XY scatter chart on this.
what's the, oh,
So that's the one we're after.
that's the one that mine shows up as. Official picture. Ours built it correctly.
Oh, really? That's good. So that's what it should look like. Now, why isn't mine looking that way? I've got a slightly different version of Excel than you do. This is Excel 2009, which still, last time I ran this on Excel 2009, it worked. But let me just actually have myself select, my hunch is that needs to be selected. That if that data is selected when this thing gets built, it'll do it okay. So where does it add the chart? Right here. So I'm just gonna select that right now. Is my sheet selected already? Find frontier. I don't think I'm selecting the sheet till the end. So I'm gonna select it sooner. I'm gonna select it here. And then let me go ahead and just say that B3 range B3. What if I wanted to, from B3, what if I wanted to select all the contiguous data? What would I do? B3 dot what? Very good. Current region. Dot select. Capitalization doesn't matter, but the editor, if it recognizes, it will push it to the right capitals anyway. So yeah, looks like that's just what it needed to be able to have that range selected when it built the chart. Then it builds it right. Whew. Yes, question.
Why are like the first lines of data identical, but is that a constraint that's making all of those so similar?
So why are these all the same? And so it's not a constraint. It's just saying that there is that all of these are going to get us that this is the lowest risk allocation of this stock, anywhere from what we're starting at, this lowest required return, all the way up until the first place it changes, which is right here. So this allocation is going to be the minimum. It's going to give us the minimum risk and still meet the required return. And that is true. We don't have to take on any more risk. As we look at this, yeah, right, the risk is the same. We don't have to take on any more risk to be able to get that expected return. And so it's saying lowest risk, that's the one we're going to go with. As soon as we say, we're no longer able to get the expected return with that allocation, now we have to take on more risk to be able to get it, which is why those are the same at the beginning. I feel pretty good about answering that question because that's kind of a financy question. Yeah. Oh, good. Whew. That's right. Little applause here for the IS guy. Okay. So we have some options. This is really done with the content that I wanted to cover today. We could go back and kind of take a look at how we're actually working with that API. So kind of what's the mechanism to pull that data in. I could dismiss class early. Either way, I'm going to give you some bread that I made. Do I have enough for everyone? Like more of you came than I was expecting to come today, but so yeah, I will tell you the story of this bread. So here, I'll show you a picture, then we can decide what to do afterwards. Maybe you can come down and arm wrestle over the bread. So it may not surprise you to learn that I do volunteer historic reenactment education work. I do. So here's me as the colonial baker. This is the activity where the user form project came from. I think you would have found it, but I think the data, I just pulled the Marriott School directory. Yeah. So this was the first oven that we built. This is a dry stack oven. You move this oven by moving one brick at a time. It takes about 12 hours to move. That was a lot of work. You'd rather write VBA code. Most days I would too. The next year we built this oven, which is a little more typical of what an 18th century brick oven looked like. So yeah, I've been making sourdough bread kind of the way it was made in the 18th century for a decade or so. The Yeah, so this bread has only 3 ingredients. It has water, flour, and salt. Actually, I was making this for my IS student class. I have 200 students in that class. And on 70 of the loaves, I left out the salt. Yeah, if you've ever had bread without salt, it's like kind of like eating French fries without salt. You think, why would I eat this? And anyway, so I thought, well, maybe someone will like it. So this isn't my best bread. This is bread without salt here. But I ruined like 72 loaves bread that way. I gave away, bread to everyone that I already knew. And I thought, oh, you know what? I'll have some students here. They can take the rest of my bread today. So yeah, the oven's kind of interesting. The way it works is you build a fire on the inside and you burn that fire for about 20 hours to heat up the brickwork around it. You take out all the fire and then you just bake on the retained heat that's there in the oven. Bake on retained heat, yeah. In fact, in the 18th century, baking means cooking without fire. So you're cooking where there's no active fire. How do you get the right temperature? No vents. Yeah, it's a completely closed system. You heat it up, and when you're done heating it, it's too hot. So you wait for it to cool down a little bit.
How long does it last until you have to fire it again?
So it depends. The question is, how long does it last until you have to fire it again? And the answer, it depends on how much thermal mass there is. This oven has 9 inches of thermal mass. So if you look at this, this is the concrete hearth. And it has that much thermal mass kind of all around the baking chamber. Yeah, 9 inches of concrete all the way around. In my driveway.
Is it in your driveway?
Yeah.
Like set up?
Yeah.
Where do you live?
It's about 2 miles from. It's about 2 miles from here. I do not decorate it for Christmas. It may be that may be my real address that's there. Actually, I don't think they publish home addresses. I would be glad if you were really interested to come over. I'd be glad to have you come over and show it to you. It's really kind of fun. So anyway, so that's the spread. So if you think you might be interested, how many do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have 15. There are more than 15 of you here. But do we want to spend some time kind of going over that code to call to an API? Or do you want to get some bread and get out of here? Why don't we do this? Why don't you come get some bread? I don't know who's going to be brave enough to come make the walk down to get some bread, but come and do that. And if folks want to stay afterwards, we can go over that part of the code separately. All right, so let me come back to view my Project Explorer. And, oh no, I guess I'm on the right place already. I did not record what I just said. Well, thing is, it's going to get posted. This is going to get posted on a VBA blog, and people are going to be like,
Are you recording now?
I'm recording now. So they're wondering what I didn't record. I just didn't record talking about American history.
How did I do that solar thing? Oh my gosh, this is so awesome.
That's right. All right. So where did we should be like get data? We see get data here. Get data. Okay. So let's just kind of look over what we're doing here. So get data. This is not, get historical data is one we're after. So this gets the parameters together that we need to send to get historical data. So this is going to send us probably a stock ticker. It's going to send us a start date, and it's going to send an end date. Oh, maybe this is this is probably where it's going to put the data. This is the ticker, start date, end date, and we're getting percentage changed. Is what, actually, we're putting that into the first column of the data once it comes back. So get historical data is going to drop data into this location based on these parameters. So let's go find this one. Okay, this looks better. So The URL that we're going to have to make is expecting to have the month specified in these 3-letter abbreviations. And so when I get the month off of the date, I'm going to have to convert that into the letter using this array. You can kind of see the different places I've got the data for over the years from this example. It started at finance.yahoo.com. I got it from iChart, Investopedia, now Alpha Advantage. So it's asked, so this is the URL that we're going to ask for. So hard coded in the URLs, I'm asking for the time series adjusted monthly data we're after. I'm giving it a particular ticker. I'm giving it the API key that is the one that says, you've purchased some capacity here, and so we know what capacity you're doing, or in our case, it's free capacity. And the data type is CSV. Seems like I should have specified the month in there somewhere. API key, data, ticker. No, it's definitely using this date and month. I'm specifying this. Anyway, I'll take a little more than I'm kind of ready to review here at this moment. But then this is the part that I want to make sure you understand. We haven't seen this in class before. So what we're doing here is we are creating an object called XML HTTP, server XML HTTP. This is an object that knows how to make a request to a web server. And so what we did in class, we automated Chrome. We said we're going to open Chrome and tell Chrome to do stuff and then look at what it brought back. What we're doing here is we're making an object that it's not going to show anything on the screen. It just says, I know how to talk to a web server. And so we are creating an instance of that object. We are calling the open method, saying we're going to use the get protocol. There's like 5 different protocols you can use in HTTP: get, put, delete, update. But get and post are the ones we use the most. We're telling it to be the URL, and it's not going to be a background query. In other words, wait, pause the code here until this code comes back. So that opens it, and then the send actually sends it off. And then we'll wait till we get the response back, and that will be, our object is called HTTP, and we're going to get the response that it gave us back in this response text. Let me go ahead and just run this code, put a breakpoint there, so we can kind of see what it brought back from this. So I guess I'll just call get data. Okay, so here I should be able to ask what came back from here by asking what the HTTP response text is. So it sent the request off to the server, and it's got this response back. Looks like it sent back just a comma separated. This is a CSV file. It's just CSV data. And so this data, this block then just is going to go through that. It's going to separate that based on the carriage return character. It's going to parse this out and put all that data onto the sheet. But the thing that I think is really interesting is that without too much code, it's easy to just say, oh, I want to send a request off to a web page and get the results that come back. What is not easy with this tool is to maintain a session. So to go through and kind of log in and say, we're going to keep track of the cookie that was going to put into the browser, and we'll manipulate that. It's possible to do. It is a lot of coding to do. But if you're just going to a page that's kind of open and available without having to log in, this tool is really fantastic, and it's very, very fast as well. So that's the overview of using the XML HTTP server object. Any questions here? All right, folks, thanks for coming. And oh, yeah, one more thing, and that is, I guess that'll be it.